So imagine you have a list of numbers. It's unsorted, and you're looking to find an index of a particular number there, let's say 12. Classical computer science tells us that, well, the best you can do is to try. It's unsorted, so you cannot do any searches, and at worst, you will have to go through all of them. You're really unlucky. You always find your number as lost. Now imagine you take this gaming die, this six-sided thing that you use in board games, and you say, whatever it gives me, that would be the answer. This is useless, right? It just gives you random numbers. If it's a normal die, all numbers are equally probable. So you keep throwing it and it gives you random numbers, and you're saying, well, this isn't helpful. This is a quantum computer that is not calibrated, so it doesn't operate very well. And you did not program it well. You did not write a quantum program well enough. Now take a leap of faith with me and imagine this kind of magical scenario where you take the same gaming die and you slightly modify it. You maybe add a piece of material somewhere, like cut a corner, make one side more weighted, and you do it in a way that is somehow connected to the data, to that list of numbers. You still don't know the answer. It's not trying to trick this cube to go in the correct answer. You don't know the correct answer. But you know the shape of this list, you know some other properties, and you somehow make the cube different so that it's still random, but less so. It's less random. If you throw it multiple times, it tends to gravitate, to be skewed towards a certain number, which happens to be the correct answer. This is kind of crazy, like this doesn't make sense. But this is basically how a quantum computer that is well calibrated and well programmed by the programmer works. If you don't take anything else out of this lecture, take this. It's a very remote analogy, but quantum computing is basically trying to trick the universe in some isolated little piece for a very, very short period of time to behave slightly less randomly in a productive way that is useful to you when you solve some problem. So with that in mind, here's the plan. It's very thick, it's very dense.